Hi everyone, this is topic B, which the focus here is on evaluating functions and graphing parent functions from the graph. And one thing that's not in this worksheet is evaluating functions from a graph, whereas if you have f of 3, like in example A, and it was looking at a graph, the input 3 would be the x value and the output would be the y value from the graph. So I'm going to let you work that out from the pre-quiz. And if you have questions from the pre-quiz, please make sure you talk to your group members or ask me in class tomorrow before your post-quiz, because that's not going to be on this practice sheet. It'll be in your book though. So the first example I'm going to go over is C, where your input is 2a. And I already wrote it out, where the x value for the function f is 2a. And the reason why I'm starting here is because the most common mistake is that only the a is squared and not the 2, because this represents 2a times 2a, which is 4a squared. So you're going to have 2 times 4a squared, take away 4 times 2a, which would just be 8a. And then on the left, to simplify further, you would get 8a squared minus 8a, and you're done. Moving down further now, G and H. This is going to come up quite a bit later in first semester, where H is really what I'm leading you up to. It's the definition of what a derivative is. But we're going to first talk about simplification. So for this function, which is 2x squared minus 4x, so I'm going to write that down here just so I have it on the screen. So f of x equals 2x squared minus 4x, right? 4x, yep. 4x. Okay, so let's see how that's going to be applied to G. So first off, I'm saying my input's going to be x plus h. So wherever I see an x, I'm going to plug that in. So it'll be 2 times the input x plus h squared minus 4 times the input x plus h. Okay, now that is just taking care of this portion right here. Now I have to take away the function, which is already given to us. So it's take away, I'm going to put in parentheses, because I'm subtracting the entire function, so this negative is actually going to be distributed to the entire function. 2x squared, subtract 4x. Now it's a simplification game. So it's going to be long. I'm going to go quick. If you want to work this out longer, you can. The first x plus h squared, it is x plus h times x plus h. Quickly, it's going to end up being x squared plus 2xh plus h squared. Take away, distributing the 4x minus, because the negative is going to be distributed to both of them, 4h, and then the subtraction is going to be distributed once again, minus 2x squared plus 4x. And now we are going to be, one last time, distributing the 2 in the front. So I'm going to have 2x squared plus 4xh plus 2h squared. I'm just going to rewrite the rest of the function now. Now it's just combining like terms and see what we can combine and what cancels out. So for the x squared terms, we're going to have 2x squared and a minus 2x squared, so that's going to cancel out. For the h squared terms, I just have 2h squared, so 2h squared. That's done. For the xh's, we have just this one, so plus 4xh. And we have a minus 4x and a plus 4x, so those will cancel out. And then all that's left over is the take away 4h. Now, the next problem is not as long as this one because it's the exact same thing, only now we're just dividing by h. Notice the numerator is exactly what was in part G. So from here, I'm just going to take the result from part G, which is 2h squared plus 4xh minus 4h all over h. And what you should notice is that each one of the terms in the numerator has at least one factor of h. In fact, the first term has two of them, so there's going to be one left over. So what will happen is that one factor is going to cancel out on top with the bottom. After simplifying, you'll just have 2h plus 4x minus 4. These h's will cancel out, and one of the h's will cancel out in the first term. And you're done. So go ahead and complete the top if you feel like that's necessary for some practice, and you can check your solutions. Now moving down to the bottom, we're talking about parent functions and how to identify them from the graph. The first example is a constant function where every value, no matter what x value you pick, the y value is always going to be the same. It's always going to read across to a. So this is going to be y equals a. It's a constant function. If it was at y equals 3, it would be y equals 3. If it was at y equals 4, it would be y equals 4. But here, the graph is saying it's at a y value of a general value a. For the second one, this is the equation of a line. It's called y equals x. That just means the y-intercept is 0 and the slope is 1. For the third one, this is quadratic, and it is y equals x squared, where the point we're going to look at here for all the translations is going to be at 0, 0. So if it moves left, right, up, down, that's the point you'll kind of track. And the next one is going to be the cubic function, where once again we're going to look at this critical point, which is called 0, 0. And it's y equals x cubed. The next graph is going to be the square root function, which will be y equals the square root of x. And just like the last two, the critical function that we're going to look at is 0, 0. Next one is going to be the square root, or the absolute value function, y equals the absolute value of x. Critical function being the same as the last ones, 0, 0. The next one is the rational function, which is y equals 1 over x. Now the 1 for this example is going to be kind of generic. It could be 2, it could be any kind of number, as long as it's divided by x, in this case where the vertical asymptote is at 0 and the horizontal asymptote is also at 0. Now those asymptotes is what you'll see most shifting up, down, left, right, and that'll be displayed on what we're going to do to the y and the x values. And the bottom one, which we will talk not that much about, but you should be very familiar with it, and this is the exponential function. So not knowing what value that it's going to cross here at the x-axis, in general we're just going to say this is 0, 1. When we're looking at a function that's y equals, maybe it's e to the x, maybe it is 2 to the x, Maybe it is 3 to the x. These might be more familiar to you. Okay, it could even be y equals 100 to the x. These are all exponential, and they all have a 0, 1 y-intercept, unless the coefficient in front of the e, the 2, the 3, or the 100 is something different other than 1. Okay, but you just have to be familiar with that one, and you'll be fine. Going down now to transformations. This is for number 15, this multiple choice question. We have this minus 2. So this minus 2 is going to move the function down 2. So the 0, 0 that we saw above in the quadratic function is going to be moved down 2. So if it's going down 2, it should be at 0, negative 2. So which of these functions moved down 2, and that's all that's happened? Well, it looks like option B went down 2. So the reason why it went down 2 and not to the right 2 or left 2 is because when I look at this function, it's y equals x squared minus 2. And I could also rewrite this as y plus 2 equals x squared. So this 2 value I really associate with the y value. And when the operation is right next to the value that it affects, it always acts inversely or opposite. So if you're adding 2, it's really what it looks like it's doing. It's not going up, it's going down 2. That's something that you studied in Algebra 2. And there's nothing actually happening to the independent variable x. Otherwise, it would be in parentheses. Very similar to what you see down below in number 16, where the multiple choice is asking you, if I'm going to add 3 to the independent variable, what's actually happening? Well, it's always the opposite. So, in the x direction, if I add 3, it's really not going to go to the right 3. It's going to do the opposite. It's going to go left 3. So which of these is going left 3 and that's it? Well, once again, it's option B. And now looking down at our graphs, getting rid of some of the clutter here. The first one is going to be that constant value where no matter what x value I pick, whether it's 2, I go up and I hit 5 for the y. If I go over to 4 for x value, I go up and I hit 5 for the y. No matter what x value I pick, the y value will always be 5. So it'll be y equals 5. I mean, with function notation, you can always say f of x equals 5 as well. And now, when we compare the parent function for y equals x, well, y equals x was actually going through the y-axis and the x-axis. So really, the origin, like this. So what happened? Well, you can either look at it as you moved this line up 2, or you moved it left 2. Either one is going to be the same. So let's just say I moved this up 2. Well, move it up 2 means I'm going to affect the y value. So up 2, let's do the opposite. Let's subtract 2 equals x. That technically is the function, or we could say y equals x plus 2. Moving on, here's the cubic function. So I went right 2, up 3. So if I look at y equals x cubed, if I go up 3, I'm going to affect the y value. So up means positive, but I'm going to do the opposite. I'm going to subtract 3. And I went right 2, but I'm going to do the opposite. So I'm going to subtract from x 2, and it's still going to be cubed. Now, for this looks not